Alrighty, well, so the last couple live streams have gone horribly, but it was a good experience. I've learnt a lot, and I'm gonna try again another time. I think I definitely need to try get some better internet. That's probably the root of all of my problems. But for the time being, I'm just gonna record like last time and see how much I can get done. Yeah, wish me luck. It'll probably be pretty quiet for most of the video, but hopefully get something working. This is when the word movement. Oh, in this case, I could actually use G capital E, yay, and then RZ, and I can really quickly copy and paste that. I mean, quickly once I get used to it. It still takes a bit of time. Copy and paste the line and just replace the bits I need to replace. In examples like this where there's just lots of the same thing with very slight differences, like in this case the XYZ coordinates. Something's not right here. Vec3 is not getting recognized. Or is it Vec3D? That would make sense. Okay. How's that looking? Let's compare that to the video. Looks like I'm on track. And O is really useful because it opens, it makes a new line and is inserts at the same time. So if you're on a text and you just want to add another line, that's really great. But I wonder if there's one for just making a new line, because that would be incredibly handy. There's Control J, which begins a new line during insert mode. And there's O, which I've been using, open a new line below the current line and insert. And there's 0, which is dependent on a new line above the current line, but I haven't been able to get that working, because 0 also brings you to the first character of the line. So as opposed to Shift 6 or hat, which brings you to the first non-white space character of the line. So apparently 0 is also supposed to append something, but I haven't got that working. Let's try going into input and then Control J. I have nothing happening. How could you lie to me? Vim cheat sheet. I think it may be because I'm using just an extension for Visual Studio Code, so it's not actually Vim. If I opened actual Vim, maybe some of these commands would work better. But for the most case, it's actually a really nice map of the Vim command system onto Visual Studio Code. Okay, so let's get up here, Shift 6, and this needs to get changed to, so I can use E, and then R2, down R2, down R2. Yay! To get the line 2, though everything else stays the same. Oh no, the 2 changes, so because now in this case, essentially what this first line is imagine a triangle, and we take 2 sides of that triangle, and they meet at a point, and essentially the point which they meet at is point 0, and line 1 goes to point 1, and line 2 goes to point 2. Well, in this case, we're dealing with computer systems, so they connect at 0. Line 1 goes to exactly as I said the first time. And we're trying to calculate the normal, so the next thing I'll do is go down here. But essentially this line is we're getting it by taking the coordinates of the first point and minusing it by the 0 point, and that will give us the line 1, and for line 2, in each of the coordinates, we minus that coordinate from point 2 minus point 0, and that'll give us that line. So let's do that. This needs to be 2. So this is another thing that's so quick. So R2 down, R2 down, R2 down. Done. And down is just J in this case, which is where like your finger always sits, so J is so quick to do. Now this one is not line 1. This one will change to the normal. So Norma. No, we haven't got enough characters, so I'm going to, let's see, there's a few ways I could do this. I'm going to go V, Shift B, and then X, and then I, and then I can say normal. So down, go down to here. V goes into visual mode or select mode. Shift B will bring me to the beginning of the last word, which happens to be this word. Now it's selected, I hit X, which is just get remove, selected. I is insert on the left of the character. And then I can type normal. If I really wanted to, actually, I can make this even simpler and say V, back in select mode, go to the beginning, Shift B, go to the beginning, but this time I'm going to just hit Y, which is going to yank that, Y for yank, but yank basically just means copy, but apparently they liked saying yank back then. That's nice to display the difference between Shift E and just E. So E will give Shift E will bring me to the big end of this entire kind of unit before the next white space. But if I just hit E without Shift, it'll bring me to the end of this before the dot, which is useful. Like it's so useful having all these different commands for different scopes, but there's a lot to remember. V, now same kind of jazz. V, Shift W is the wrong one, so we go back and get here. And V, Shift B, and then this time just P for paste. Yay! And in this case, it's not going to be the same thing on the right. It's going to be very different. So I'm going to have to get rid of all of that. But that's fine. I can use another fun one, which is Shift R to replace a large selection. And apparently we want line 1 dot Y times line 2, I'm assuming. Yep, dot Z minus line 1 dot Z times line 2 dot W. Not W, Y. I don't know where I got Y out of W. And we'll just kind of get rid of all that. I have all this white space here now, but we'll just do that. There we go. X, 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 X. X is super handy because you can just remove things from command mode. Okay. Yeah, the mathematics behind this I feel like I should know, but I can't seem to see them. But it's kind of interesting, like to find the normal of X, the X coordinate of the normal, you have to multiply the Y and Z coordinates from the others, from line 1 and 2, which is everything except for Z, X. So I love it when there's like little patterns like that. I wonder if pasting, yanking and pasting works with the Shift R, the replace function. So, like any good scientist, let's try that. So, V and then Shift 4 for dollar sign to get to the end of the line. So I just selected everything to the end of the line. One thing I found which is strange, which is if we exit out of that, go back to the beginning of this area. So back to here. If you just hit Shift 4 or dollar sign regularly, it brings you to the last non-white space character in that line. But for some reason, when I do it in select mode, now I'm in select mode or visual mode, it includes the enter line. So now if I copied this, it would make a new line if I was to put this somewhere, which is not what we want. So I'm just going to hit H to go left once and get rid of that. And now Y for yank. One thing I discovered the hard way is that yanking in Vim seems to use its own like copy place. So it won't actually go to my my system clipboard. You can get it to go to your system clipboard, but it's a longer command. It's quotes plus P, Y and quotes plus P to paste, which is just a bit longer, less convenient. So you can only store one thing, and the only way you can get it to paste is by hitting P in command mode, like I just did there. Oh, one thing I just learned, U for undo. So it actually puts it to the right of the character I'm on, which means I want to be on this white space. Then P, and then from here I can move left one and just kind of annihilate everything here with the X key. Whoop, that was too much annihilation. Okay. There we go, just the right amount of annihilation. Now this is totally a very long way to do this, but I'm taking it as a learning exercise. That's actually a quicker way to do this. I'm gonna V shift back here, just kind of annihilate that. See, it included the new line there, which is annoying. I'm just gonna add a new line. But when I don't, yeah, it's strange. Alrighty, paste. That's the wrong one. So let's go up. So what I found I like to do is go the other way around. Like I always go from the end, then copy to the left, to the beginning. But in this case, I'm going from halfway through. So $, H for your left, and Y for copy, J for down, P for paste. Yay! And now we have a nice big matrix. Now well, not a matrix, but a nice big paragraph. Now we need to go through and actually change all of those. So using our handy word navigators, back, W, Shift W, I'll go up, and Shift E will get us to this Y straight on, and this Y needs to become a Z, so RZ. And then if I do Shift E twice, that'll bring me to this Z, and we want that to be an X. And the next one, so Shift E again twice, and then this one I think needs to be an X as well. Yes. And the next one needs to be, oh, this case we have a semicolon, we can't really do much about that, so I'm just going to left. And we're going to, this one should be Z, I think, RZ, yay. Alrighty. Oh, what have I done? There we go. I did Shift W instead of Shift B. I'm going backwards. Alrighty. So Shift E, bring us here. With Z, so I'm gonna guess, following the pattern above, this is gonna be an X. And then Shift E twice. This one should be a Y. Shift E twice. This one should also be a Y. Shift E twice. And H left. This one should be a X. Is my guess. Eureka! I got it. Okay, so that's our normal vector of our triangle defined. So now he was just saying that one more thing we need to add. So this is where the handy O to insert a new line underneath comes in handy. So we need to get the normalized. One thing with linear algebra and vectors and all that, which I always find annoying, is the normalization and the normal are two entirely different concepts, and it confused me so much the first time I came, because I was trying to read through my old code and it said normal everywhere, and I thought of like a normal as in, oh yeah, that's like the thing which is the opposite of parallel, right? So it's going 90 degrees of the current vector or the main vector. I was like, oh yeah, that makes sense, but this doesn't make sense in this context. What's going on? It was normalized, not normal, but it had been, as programmers like to do, we shorten things. So normalized becomes normal, which also happens to be another entirely different mathematical concept. But in this case, we're using the normalized part. So the above is the normal as in the normal vector, and below is normalized, what I'm writing right now. Okay, so square f normal.x times, well, okay, that's interesting. It just does it twice. I guess there's no square to the power of operation. plus, I guess it's just Pythagoras' theorem, normal dot y times normal dot y plus normal dot z times normal dot z. And that should be it. Semicolon. Normal dot x divided equals 1. Interesting. Normal. Ah, it's L. That would make more sense. I was really confused about the 1 being there, and it's because it's not a 1, it's an L. There we go. So that should be an L. I guess L for who knows. Okay. So end shift E twice. Normal dot y divided equals L, so that's the same kind of thing. A to insert to the right, normal dot y divided equals L. Normal dot z divided equals L. Fun, fun, fun. Okay, so it looks like now we're gonna chuck all of our drawing functions, or calls, into a nice if statement. Because now that we have this new normalized normal vector, this normalized normal vector, essentially what we're trying to do with this is make it so that if I run this program real quick, so looks like my program isn't quite set up, so let me just fix that. Please. Yep. Okay, that is the program now running. So this program, as you see, I mean, it's currently filled in. So this is what I made in the last one, playing his video. I'm currently filling in triangles, but let me just comment that out real quick. Yep, so that's gone. Now we're just going to draw the lines between the triangles. So as you see now, it's just a wireframe. And it's kind of weird to look at because essentially each side of this cube is made out of two triangles put next to each other because graphics likes triangles. GPUs do, I should say. So at the moment though, it's drawing every single line of each triangle, even if they technically would be out of view. So we're seeing through it as if it's a hollow cube, which it could be, but in our case, let's say we don't want to do that. We only want to see the sides we're supposed to see. So one way that we're trying to do this is by calculating the normal to each of these triangles, which essentially just means an arrow sticking out of the triangle towards the side it's facing. So yeah, it's essentially pointing outwards in all directions. And that way we can easily calculate, in this case, in this simplified scenario, the camera is roughly at 0, 0, and the cube has been translated about 3 units forwards in the z direction. So if that normal, when we calculate it for each of any of these triangles, is less than the z component of that normal is less than 0, i.e. it's negative, it means that face is facing in the opposite direction to us. And if that face is not facing us, well, obviously we can't see it. So what this if statement will do is just chuck out all of the drawing here we are. It means that it won't draw things we can't see, which is what we want. So what do we want to write? If normal dot z is greater than 0. So i.e. less than. Oh yeah, so no, it's the opposite of what I was saying. If the z component is negative, it means it's facing towards us because it's been translated into the z direction. But if the normal of the triangle is positive, it means it's facing towards the z direction, which is the opposite direction of us. So we've got that if statement, and now we just chuck it into a big brace. So just here again. It's not giving an error, which is worrying. What have I done? Oh, okay. I've just replaced that one with that. Does that work? No, something went wrong. It's not saying. Oh, yeah, it did work. Oh, wow. Okay, so even just with that simple addition of code, it now, very clunkily, is attempting to not render things out of vision. But as you can see, it's not doing a very good job. That's interesting. So it's only ever really, there should, by the physicality of the cube, there will only ever be 3 sides possibly facing us. So as you can kind of see, there's always 3 sides that are being rendered, and once one of those sides it thinks it's gone out of view, it stops rendering it. It's kind of satisfying to watch. Alrighty. Well, moving on. Success number 1. So it looks like he's saying the way to fix this weird behavior is to define a camera. Essentially, at the moment, it's not taking projection into account. which means that it's kind of assuming that we can see everything along the entire XY plane, which is obviously not the case. We have a field of vision when you're as humans and just and cameras or anything looking into 3D space. Of course, we're seeing a 2D projection of space, and there is a limit to that field of view. So at the moment, it's calculating as if we could see everything when we can't in that plane. So yeah, we need to add in the field of view into the calculations, and the best way to do that is with a camera. Apparently cameras are really complicated though, so that's going to be another time. For now, we're just setting a vector, defining a new vector, which is the location of the camera in space, and we're going to define that as 0, 0, 0, and it means the camera won't be able to move, I guess. I'm not quite sure what that exactly means, but that's what we're doing now. So let's define a vector, a position vector for the camera. I do find myself just using the scroll wheel to scroll through the text a lot still. There's definitely not the scroll wheel is hard to beat. I'm looking for private, public. This is where okay, I found it. Alrighty. So no, not capitals. Vec 3D. V camera. And semicolon. Fun. Alrighty. Alrighty, handy search. So apparently we just want to comment this out for the time being. Bye bye if statement. Where's the normal? Okay, there we go. Sometimes it takes Visual Studio a bit to update. And replace that with a new if statement. So essentially our fix to this problem that I was just talking about before is that we have to take the perspective of the viewer into account, the field of view. And so something that is useful for keeping things in perspective is the dot product. Because if we imagine an imaginary line coming from where we sit and from our eyeballs towards the point in question, let's say in this case it's the position of the normal vector, and if that, we can compare how similar those two vectors are. So the normal vector that's facing out of the side of one of those triangles, and the vector going from the eyes to that triangle. And of course, if they're, essentially what the dot product does is if they're in line, i.e. parallel, it'll give us either a 1 or a -1 if we normalize the vectors. However, if they are perpendicular, i.e. completely unrelated to each other, it'll give us a 0. So what we will do right now is what I'm checking in this if statement is going to be a pretty big if statement. I'd usually probably make a function for that myself, but I'm just following the tutorial for now. So we're making the condition that if the dot product of the normalized normal vector of one of those triangles and the vector from, or the position vector from us to that triangle, if we dot product them together and we get a 0 or less, it means it's facing us. I think less, or maybe more, one or the other. It means that it is facing towards us, because those two vectors are roughly in the same direction. But if it's negative or it's 0, it means it's either in the opposite direction or completely unrelated, i.e. perpendicular. So in either of those situations, we don't want to be drawing that face. It shouldn't be visible. So yeah, that is what I'm coding now. Let's see, yep, okay, and plus. So, what I've just written here, there you go. Yank. Still can't get over that. paste, down, paste. Okay, and both of these should go up quite a bit. Another handy Vim command is just double hitting shift dot or shift period, i.e. the right arrow, twice, will indent the line, which is nice. Very handy. X input 1, 2, 3, make it nice and pretty. J put down. H left, X, I, space, space, space. Yay! And then we want to go to the end of this line, get rid of that, and insert a close bracket. Okay, now we want to change all of these values. So, oh, I've got a bit missing. I forgot about the entire right part. Let me just yank that part. And now this is interesting. I'm interested to see how it replaces white space. My prediction is that it's going to shrink this line. So paste. I didn't. That's cool. Alrighty. Down and oops, back. Forwards. Left a bit. And paste. Alrighty. Okay, no, so just it inserts it essentially. So it didn't short the line, it extended it. Oh, that's because I didn't do what I was actually meaning to do. I was meaning to do your left one, up, down, the way around. There you go. Shift R, and then paste. Ah, you can't paste there. Okay, interesting. Can I do Control O, P? Nope. Okay, never mind. Alrighty. So, left. We'll just nuke this white space with the beloved X key, and that looks much nicer. Okay, so now I'm going to replace some values. Going up, I'm going to replace that with a Y, I'm assuming, and this one with a Z. That would make sense. And I'm assuming these ones. I think this will become a 2, and this one will become a 1, is my feeling. But let's check. Oh wait, actually no. Let me just think this through for a moment. We're only taking from point 0, so these should stay 0, because point 0 is the starting point of our normal vector. So we want those to remain 0. What we want to be changing is the component. So y, z, x, y, z. So this way we're taking the x, y, z of we've taken the x, y, z of the normal, because that's the one we're comparing, and then to get the position vector between the camera and the point 0 of the triangle, we just minus the camera position from that triangle, which is just pretty standard. If you want to get a line between 2 points, you minus the the beginning point from the after point. It's kind of like delta. Anyhow. And we're only worried about point 0 in this case, because that's our point of interest, and it's just taking the x, y, z and timesing them all together. So that is our value now. And now what we're interested in is what that value is. So I think we're going to be comparing whether that is... let me just think about this for a moment. It's facing towards us. It will be negative So I think less than 0. But let's see what happens. I got it right. That makes sense, yeah, because essentially what's that saying? What the dot product, treating the dot product as a magical black box, which does magical things, but we know what it does. And what it does is we give it two vectors, and if these vectors are pointing in the same direction, it'll give us a positive number. If they're pointing in the opposite direction, it'll give us a negative number, and if they're perpendicular, it'll give us a 0. And we want to know if if the face is facing towards us. So essentially, the vector to the position vector to the camera, and I mean, you could change it all just by changing around the equation a bit, but we want to know if they are going the opposite direction, because that means they're looking at each other. So less than 0, and that'll keep that condition satisfied. And floats are just nice, so. Now let's try that. Oh, we have a problem. There is a unwanted DD. Little bracket there. Alrighty, B. Let's see what errors we get. Hey! That's actually really nice and smooth. Oh, that's so satisfying. Oh, I saw a slight error there somewhere. How's that looking on the screen? Just gonna make it a little bit larger. It looks really satisfying. And it's nice because I've got it on the 720p, so it actually looks pretty high definition. I mean, the video is being recorded in 480p, so I don't think you'll be able to see that. I could stare at this for a while. For ages, I always wondered how the hell computers calculate 3D graphics. I was like, I had no idea how it worked. It really interested me. I was playing around with 2D engines back then already, and also a bit with like Unity, Unreal Engine. And all this 3D graphics, which was amazing, but they were really like big black boxes. I had no idea how they work, and I'm really, really happy to be actually learning some of the basics behind it. We have a wireframe that's going through space, although we're completely stuck in space. I can't move around, and the camera. There's a lot of assumptions in this situation, so it's not very perfect, but it is looking nice. And it's all just mathematics, really. Like, the code, of course, is necessary to make it an actual application, but really it's just mathematics, and what it is linear algebra. Matrices and vectors, cross product, dot product, matrix vector multiplication, also matrix multiplication, which we're not actually doing right here. We're just like sending the values through multiple matrices individually, but we could, and it probably would be better. So I think we're gonna, in following videos of the tutorial series, I think he redoes it, to just do a huge matrix multiplication, one after the other, but in one big fell swoop. I don't actually know how performance-wise that will be, but anyhow. And it's cool because in my first year now at university, that's all I've been learning at mathematics, is all linear algebra, also a bunch of other stuff, but it feels like a really nice time to be doing this project because it's really bringing a lot of the stuff I've been learning into practice, into actually how do we use these amazing tools to create cool stuff, and this definitely has me happy and impressed. I'm really curious now, before I move on, to play around with. Okay. There you go. To play around with the shape of the cube now. So here is our cube, defined point by point. And we can do fun stuff with it. So let's just change something completely random. Like make the south side 3. Oops. And now we're just gonna have a nice spike coming out of our cube somewhere randomly. Yeah, so that breaks the system a bit. We're gonna have a spike just randomly pop into existence. That's fun. Let's try to do that with something a little bit more reasonable, like 2. And then make this like 2 as well. Now we're just gonna have a hole in our cube. This is fun. Magical broken side. So that's really nice though. You can actually kind of already get a sense of that 3-dimensionality of it. We've got a triangle sort of sliced straight through a cube. So nice. Okay, let's just get that back to normal. Just double check that it is back to normal. Yep, that looks like a cube to me. No weird spikes sticking off into the distance. Alrighty, let's move on then, shall we? One really cool thing that David just pointed out in the video is if I change the condition slightly, so that now instead of checking for things less than, we're looking for things greater than 0. So let's replace that with a greater than. And what that is essentially doing is instead of checking if the vectors are in line or facing the camera position, it's going to check if they're facing away from the camera position. So just to run it and check it for ourselves. It's now essentially an inside-out cube, which I thought was pretty neat. It is like yeah, it's kind of it's a funny, it's a very strange thing. It's almost like it's a box, but then every time the one side disappears, another side comes back. It's amazing how just with this simple, well, I say simple, mathematics creates such a amazing, like pretty accurate model. Actually, very good. Like it looks amazing. I'm pretty happy with that. Alrighty, let's undo that change. Just double check that the code isn't broken, because that always happens. Yep, that looks good. Alrighty, I'll be back. Alrighty, so it looks like now, if we go, I did this in the last video, but right now we've been drawing the wireframe, but we can also fill the triangles if we want like a solid object look, which I have down here. Now that I think of it, yeah, I can just replace this. So, Shift R, FIL, escape, sweet. And just by changing that one line, of course we have an error. Replace an F with a capital F, then build. Now we have a solid looking object. But it definitely looks kind of like a cube, but it's not shaded at all, so it's hard to see what it is really. Sort of breaks our eyes, because there's usually never a time when we can see things with no light. So what we want to do is add some light so we can get illumination, and then we get the feeling of a solid cube. The only thing is lighting is difficult. So the method that he's incorporated for this simple example is just to have a single vector which represents the direction of all light in the entire world, which is kind of unrealistic, but it'll give us the results we want for now. And so well, that works as well. Question mark. I don't know what the difference is, to be honest. Let's say / project triangles. I don't have that comment, so let's try it the other way. You know what? Let's just find it manually. I think that's the one we're looking for. Just below the if statement. Okay, right here. So, new line. Okay, / illumination. Okay, enter. And so we want a vector now, a vector 3D. In our beautiful vector 3D class, or struct, called light_direction. Equals 0.0f, 0.0f, and minus 1.0f. F just meaning float, which took me a while to understand. So we now have a nice little array. Why is it in curly brackets is my question. I actually don't know for sure. But I'm just gonna trust that it's right. Add some space there. No line. And now we want to normalize that. So L is using the same thing again, which I don't like, but I'm actually going to go with it. Square F. Right direction dot X times. Just this again. You know, I might just copy this because it's a pain to type out. So get out of insert mode and go left. Go to the end. Go to the beginning. Yank that. It's going to take me a while to get over that. And then paste it in over here. I suppose we want to go to the end, beginning, and X that out, and then paste that in. Okay, and then just chuck that on the end. I don't know. Put that right here. Didn't get yanked. How dare it? I'm just gonna do this normally for once. Just cause Oh, you can't actually see my pop-up screens when they come up. That's interesting. I have a right-click dialog that's popped up right now. I'm using to paste that in, but it seems to be invisible to your eyes. And now we want to normalize the vector using L. So light direction dot x divided equal L. And the same thing for all of the other components. Dot y divided equal L. And light direction dot z divided equal L. Nice. Now we have a normalized vector, except it is not being defined to anything. So let's fix that real quick. So what was it? Light underscore direction. No. Light underscore direction equals. Okay, happy times. Something's not happy. Oh no, what am I doing? I just had a complete brain dead moment there. That was totally not necessary. Okay. So we want now to get the vector dot, the dot product of that with the normal of the triangle in question. So another long thing. Light underscore dp, let me say, equals normal dot x times light direction dot x plus normal dot y times light direction dot y, and so on and so forth. That should do the trick. Alrighty, and now we have that normal. Now it's just a question. So we've now calculated the amount it should be lit light, and essentially we're using the exact same method we did for figuring out whether the triangle is in view, to figure out whether that triangle should be lit. And it's just seeing how similar, or again, so if the light vector is facing towards the normal vector, they're facing each other, then it gets a lot of light. So I guess at 90 degrees it'd get, at completely parallel it'd get the most, and then at 0 or anything negative it'll get, anything positive, it'll get no light. And then we just have to, now we've got that mathematics, so we know how much it should be lit, but we don't have the means of actually shading it. So let's program that now. Okay, so to program that color, we essentially just take this dot product value. Where did it go? This one here, the light dot product, and use that as like a factor which changes the color of the side. So in the tutorial video he's using a console, the console engine, which that I'm watching, which means he's having to deal with characters and having to do some shenanigans to get color to work with that. For me, I'm using his more recent pixel engine, which is just dealing with pixels. So I should be able to just essentially change the color. So try to translate it, which is the triangle after getting rotated, dot color. I don't know if this still works in the new engine. Equals No, it doesn't work. So what can I get? Dot. I'm not quite sure how this works. I'll be right back. Okay, so I think I figured out what I wasn't understanding. Because this triangle class is something that is declared and defined in this file. So there is no .color variable, no attribute to that structure. Actually, it is. But what he's done is just gone and added that off the scenes, which he's done quite a few times now, which always confuses me. So I'm going to add that here. So here we have that structure. So we have triangle. And we want another variable, which is going to be, I guess, float? No, int. It would be int, wouldn't it? Int color. You just don't cull. I don't know. I like having it full out, so I'm going to write color equals. Actually, I don't need to say what it is, but I think it's going to be a list of 3, possibly. And end that. Let's see how that works. I just needed to double check that. So essentially, what we're going to do then, we've made declared a variable, a list, which is going to be a color. Then using our dot product, we're going to make a different value of white. So it'll just be something like, I'm just going to write some code. I'll most definitely have to change it soon. But like light underscore dp. I don't know what values that's going to spit out, but I'm going to times that by, let's say, 100. And then just do that for the RGB values. I don't know if I can declare things like that in C++. It feels right coming from Python, but it may not be. So we'll see if I have to change that. And what I want this to do, we'll see if it actually does what I want it to do, it's very unlikely, is it's just going to be increasing or decreasing the RG and B values depending on how similar those vectors are. So if it should be more similar, it should be more white, and less similar should be less white, and that should give us some kind of shadow sort of looking thing. But this is, yeah, I highly doubt this is going to work. What's going on? Times 100, times 100. Yeah, what's going on here? It's having a problem. I'm going to do this the long way. Well, first I just want to check that this is even the right thing to be doing. So I'm just going to ignore that this code is angry at me at the moment. This one's also angry at me. I thought it was public by default. Well, before anything, I just want to check, what does this fill function take? So this fill function, fill triangle, is something I've I'm using from the Pixel Game Engine, which is this very nice big file. But it's so nice because it's just a single header file that you have to import. That has everything in there that you could possibly need. And it's ginormous. But somewhere in here is a function which is this fill triangle function. If I search for it, it should actually come up. So, fill triangle. There it is. So that's where it's declared, and somewhere else it'll be defined. I could actually, that's one way of finding, if I say fill, and right now I'm just using the VS Code one because I haven't learned how to switch between multiple searches just yet. What does it take as its, actually even that first one should give me the information I need. So, int fill triangle. I think there's a legacy version and a regular version here. It takes a pixel class. So I'll actually have to declare a pixel. What is pixel? I'm not currently putting in there. Let's see. Fill triangles. The top one is the old one. I think the bottom one is the new one. I couldn't figure out what this VI2 is. I think it's a vector 2D, but I'm not working with vector 2. I'm dealing with vector 3D, so I didn't know. I was gonna have to make a new vector for that, and I didn't have the. I wasn't able to call the class, the structure, and make an instance of it. So I'm not quite sure how to use that just yet. So I just use the legacy one here, which I think is from the old way it was defined. It's just here for backwards compatibility. And that is where you define each x and y component individually instead of using a vector. I'm also not quite sure what these constants mean. Does that mean we can't change them? So that's pos1, pos2, pos3. Then it's got one for pixel. Pixel p equals. So yeah, you get a pixel. By default, it's OLC white. And what OLC white is it's a pixel which is white. But that is defined in here pixel class, which is a class in here somewhere. Oh my gosh, there's so many. Can I go to the first one? It's mentioned 551 times, please. Can I go to the top? Shift. There we go. Okay, that got me there somehow. I don't know what I've done. I'm going to move myself to the top. Control F. Control F. Oh, I'm back in command mode. Back in insert. Control F. Pixel. I just want to find the pixel class. Oh, I can do this. Oh, wait. OLC. Pix. No. The header file is so big I can't find it. Oh well. I'm just gonna try and declare one and see what happens. So if we go up, instead of changing the color, I think we'll want to create a pixel just before draw time. So let's say we're right here. you want to make an OLC pixel, not a pixel, a pixel. So how did I do this again? I've already forgotten. And let's just say pixel. And that way we have we've defined or declared a new instance of pixel. It's not giving me errors, so I'm going to assume that that is the right way of doing that. But now how do we access the pixel's color? Pixel dot. Oh, we have a lot of fun stuff here. Fantastic. This is what I wanted. Control and what was it? Control. Oh, that wasn't it. So we're looking for something like color. A, B, G. Alpha, custom, A, B, G, N. I'm not looking finding anything that looks like RBG. Let me just check the docs real quick. I'll be back. Okay, yeah, it was pretty much what I thought it was. It's pretty simple. It's just for some reason R wasn't. Let me. There's no stuff going on. Eyepiece. There we go. Something wasn't going right. The R for some reason isn't popping up here, which confused me. I could find B and G and A and N. There was no R. I was like, what's going on? But if I do R, it's there. Okay, thank God. And I can just set them manually, right, like this. Equals. So I can just actually go color, for instance, 0. Not color. Try projected dot color 0. And then that. Is that the right way to do it? That seems to be working. I'm going to do that for all of them. So let's do the thing like always. Go back into control mode. Go to the end. V. Go to the beginning. Yank it. Go down. Paste. Make a new line. Paste. Go right a bit. Alrighty. And now we want to change this to a B. And this to a G. We now have RGB. Yeah, it's pretty intuitive enough. But basically all the pixel class is just a single. It just contains its color and alpha, and I think that's about it. It doesn't really contain much else. So it's a pretty simple class, easy to get your head around. That's nice. 1 or 2. Okay, now let's try and check if that did what it's supposed to be doing. The way he's doing it is feeding the color through the whole way. Actually no, that's exactly what I should be doing. I'll do that then. So yeah, okay. Try translated, got color, and I'm just gonna do it manually because I'm not quite sure. There we go. Okay. So 0, and then go back here. And just kind of exterminate everything that I don't need. That was a little bit too much exterminating, as you 100. Alrighty. Now let's copy that. Yank. paste. Paste. There we go. And change things a bit. That was the wrong one. There you go. 2. Hop 1. And that's it actually. Maybe I could have defined them all at once, but in case I change it later, this is good for now. Now let's check that, see if that happens. Okay, now I just want to feed this through every time it goes through a matrix multiplication. So here we're making the translated into the projected. Is that how we do it? What about try projected? Where's all the other? At the moment it rotates all of the, I suppose it should be rotating all, so it gets rotated, gets rotated, gets rotated. What does this mean? Try.translated.p. Oh well. Don't have to just go over it right now. So we have my try.translated.color. Now we need to get the try.projected.color. So here we get the projected matrix, and now we just want to at the moment none of this is actually how it should be. All of this should be inside the if statement. So currently it's been drawing all of them. Wait, that makes no sense actually. Yeah, it hasn't been drawing all of them. It's currently working, isn't it? Oh, that's because white space doesn't matter, of course. The joys of brackets is that it does make what should happen? Yeah, okay. Even the white space doesn't matter. Coming from Python, I was like, how is that in the same scope? It's not working, but it's perfectly fine because there was a nice little orange bracket right here keeping it all together. Okay, so I've been rambling a bit. How do I get back on track? So after we have translated, we've done our matrix multiplication, and we now have a try projected. So we want to set try projected dot color to try translated dot color. All we're doing is just feeding it through, so we can keep that value in the latest version of the train. Let me just do the same thing for the other ones. Oh, that's it actually. Is that it? No, okay, so color 1. Color 0. Color 0. There we go. It's yanking time. So to the end, the beginning, yank, down, stop selecting anything. That's weird. Why? I just paste it in. I can't paste either. What? What's going on? No. When in doubt, give up and get to and just use copy and paste. I suppose that's the advantage of using Vim inside of Visual Studio rather than on its own, because I still can do this. Alrighty. Okay, that's gone through. And now we declare a pixel with the new color, the colors. Let's try check that pixel in. So pixel. Pixel. Okay, the moment of truth. Shall we see if that worked? Oh, there's something going on. Right, just gonna exit that. Yeah, Control B. I'm really interested to see what happens now. High likelihood something. Oh! Oh! It worked! Would you look at that? That simple algorithm worked. Oh my gosh. That was actually fun because for the rest I've pretty much been following Javid's series video almost one for one. I changed a couple variable names, that's about it. And the only other main difference is I'm using the Pixel game engine, he's using the console game engine. So there's a few differences in the way functions are called, but they're very, very similar. He's made sure to keep them very backwards compatible, which is great. But in this case, it is very different. How color is treated is completely different. So I basically have to figure this out. Somewhat on my own. You just saw me worrying about it and trying to find an option. So yeah, now we have a pretty dark cube, and that looks really nice. It's of course one of the, like a horrible way of simulating light. So it looks very unrealistic. But it gives us the feeling of, yep, that's a cube. We can see the sides now. It has multiple sides. It's not just a big blob that looks roughly like a cube. And now I can do fun things, like defining the colors in a slightly different way. So now I can control how much of each color I want. So let's say I want to make it look kind of like a blue cube. RGB, so this is blue. And I'm going to make that 50. Sorry, 200. Control B. Hey, it's a blue cube. It's kind of purple actually. That's so cool. Oh, I'm so happy with that. I'm very happy with that. It looks crisp. Yay! Alrighty, well, let's see, how much more of this video has they got to go? About halfway through. Let's see, I might even call it there for a night, or a session, because that looks pretty good. I have now shading, which is a big accomplishment. But the next steps is making object files importable, which is going to be very fun, which means I can just get any 3D model on the internet and chuck it into this simple renderer and get a very, very limited rendering of it. But I feel like that's going to be quite a lot more work, and I had a lot of trouble with getting this live stream working earlier. So I think, not to burn myself out, I'm going to leave it for the night. Alrighty, thank you so much for watching. I hope to continue making these kind of videos, just because it actually helps me a lot learning, I find, because this is all just a learning experience for me. I'm basically copying someone else's code. I guess that's what everyone does in the beginning. And it's really helpful just to kind of try and explain these concepts. And it feels weirder just doing it to myself, so it's nice when I can at least imagine there's an audience. Yeah. So thank you for watching, and I will see you in the next programming session. Bye for now.